Hi everyone, welcome to my channel again. Today we're going to continue solving the Kc expression, but we're going to now determine the concentration of the unknown substance at equilibrium given the Kc value. So let's get to it. We are told that carbonyl bromine decomposes into carbon monoxide and bromine according to the following balance equation. So we are given the balanced chemical what? Equation over there. We are also told that the delta H of this particular reaction is greater than 0, meaning that this reaction, it is absorbing what? Heat. It is endothermic. Initially, carbonyl bromine gas is sealed in a 2 decimeter cube container and heated to 73 degrees Celsius. The reaction is allowed to reach equilibrium at this temperature. The equilibrium constant for the reaction at this temperature was found to be what? 0,19. So we know that the Kc value at this temperature for this reaction is 0,19. Okay. Then at equilibrium, it is found that 1.12 grams of carbon monoxide gas is what is present in the container. So what is this? The carbon monoxide that is given to us, it is part of the product of this particular reaction. So at equilibrium was found that it is what? 1.12 grams of it. We know that on our Kc expressions, we don't usually deal with what? With masses or grams. So what we do, we want to make sure that everything is converted into number of what? Number of moles. Same as what we used to do in what? In stoichiometric calculations. We convert everything first into number of moles and then use that to determine the concentration if we are asked to determine the concentration of the node or the percentage yield depending on the type of question given. So in this case, we're going to apply the same grade 11 content but into the Kc what? Expression. So let's get to it. So we know that number of moles of what? Of carbon monoxide at equilibrium was found to be what? It is expressed as the mass of carbon monoxide at equilibrium over the molar mass. Now, what is the mass? The mass is 1,12 grams. And the molar mass of carbon will be what? The molar mass of carbon, it is 12 plus the molar mass of what? Of oxygen, which is 16. So basically here, we are determining the what? We are determining the molar mass of CO, carbon monoxide gas. Okay, not CO2. I almost overtaken to say CO2. It's CO. Okay, now let's get to it. So we're going to have 1.1 divided by 1.12 divided by 28 because 12 plus 16 is 28, which will give us 0,04 moles. You can punch it on your calculator and you should get 0.04 moles. So this is the number of moles of carbon monoxide at equilibrium. Now, remember from the last video I said to you, once you're dealing with Kc expression, it is best to draw the what? The table. Using the table will help you a lot in making this whole calculation what? Easy. So let's get to the table. So I'm going to draw the table for you quickly. Draw the table fast. So we're going to have our COBr2, isn't it? To form what? CO and Br2. Okay. And this is our what? Our reactions. Then let's get to the ratio. We're going to have our ratio This will be expressed as our stoichiometric coefficient, this ratio, and then followed by what? Followed by initial moles and then followed by what? Followed by change in moles and then we're gonna have what? Our mole at equilibrium, and then the last one will be our concentration at equilibrium, which is equals to number of moles at EQ over volume. Okay, so that is easy. That is easy to deal with, this one. So let's get to it quickly. So what do we know? We know that initially we don't know how much of COBR2 is given to us, but we know the stoichiometric coefficient of COBR2, which is what? Which is 1. It's just next to this particular molecule. So how many molecules of COBR2 do we have here? It is just one molecule. How many molecules of what? Of CO, which is carbon monoxide, do we have here? It's just one molecule. And how many molecules of Br2 do we have? It's just one molecule. So the ratio will be 1:1:1. And initially COBR2, we don't know. It's what? It's moles. So the moles will be X, maybe. We also know what? We know that at equilibrium, the CO, the mole at equilibrium, they say at equilibrium it is found that 1.12 gram of carbon monoxide is present in the container. So at equilibrium 1.1, it is what? It is present in the container. So which means we have basically calculated the what? Our concentrate, our number of moles. So we converted that mass into moles. So we will say, in simple language, at equilibrium, we've got 0.04. So the mole of CO at equilibrium is 0.04. Okay. And we know that initially when this reaction starts, we are starting with X unknown COBR2, but we haven't yet formed the product. So which means CO will be what? 0, and Br2 will be what? 0. So initially, we haven't formed any of the product. We just have our reactant, hence 0. So what we need to do is to get the change in moles. Remember, we are forming the product. So it will be what? Plus. We are forming. So how will we find this? We know the initial moles, tick. We know our moles at equilibrium. So how will we find the change? How will we find the change? That should be very, very easy because we know that this plus that is equals to that. So basically I can say 0 plus this. We can call this y. And the coefficient, since it's 1, is going to be 1y, which is just y, equals to 0.04. So what will be y? 0 plus y is just y. Therefore, it means y will be what? 0.04. So it means, in simple language, our change in moles is still 0.04. And since CO ratio is 1:1 with the Br, it means the total number of moles of what? Of CO is the same as the number of moles of Br. So the change in moles will be the same. So it's going to be the same what? 0.04. Then I have to add this plus that will be what? This plus that will be 0.04 again. So I managed to find my mole at equilibrium for Br2. Now we've got a problem this side. We've got a serious problem this side. Since we don't know our our mole at equilibrium for COBr2. But we know our change. Our change in mole, since we are consuming this, is going to be negative what? Negative 0,04. See? Because COBr2 is being consumed. Remember from the previous video, I showed you that when you are consuming something, you are subtracting it. When you are forming something, you are adding it. And we're going to apply the same ratio. The ratio is still 1:1. So since it's 1:1, then the number of moles are the same. And hence, I use the subtraction to show that I am consuming. So if I have to determine my mole at equilibrium, I will say x minus 0.04. Okay. But there is another easy way to calculate that. So we will say x minus 0,04, since I'm going to add this and that. Okay? So it's going to be x minus 0.04. All right. So we are almost there. We are getting to something. Now we need to find the concentration of this. So the question says calculate the equilibrium concentration of COBr2 gas. So they are looking for this guy. So how do we do that? Easy. Now we know the volume. The volume of the container is 2 decimeter cube. So the volume of the container is given to us as 2 decimeter cube. So which means I will take all of this mole at equilibrium, divide them by what? By 2. So it's going to be x minus 0,04 all over 2. That will be the concentration. And then 0,04 divided by 2 is what? 0,02. And same story here, it's going to be 0,02 because the volume of the container is uniform. It is constant throughout. Now, let's get to even more interesting calculations and finish up with this. So we will say, let's make the background black, keep it the same. Okay, we will say Kc is equals to the concentration of the products. So what is our product? It is our CO raised to the power of 1. Remember, stoichiometric coefficient of it, the ratio, multiplied by the concentration of what? Of another product, which is Br2 raised to the power of what? 1, all over the concentration of what? The concentration of the carbonyl bromide. Isn't it so? Yes, the carbonyl bromide, which is COBr2, and is also having the stoichiometric coefficient of 1, since our ratio there was 1. Then we can substitute from here. We know the Kc, it is it was given as 0,19 equals to, what is this concentration? The concentration, it is 0,02 multiplied by 0,02 all over what? All over the concentration of COBr2 to the raised exponent 1. So they are looking for the concentration at equilibrium. Basically, they are looking for this. Okay, they are looking for that. So we need to make this subject of the formula. So I will say the concentration of COBr2, see I'm using the square bracket to indicate that is concentration, is equals to concentration 0.02 what squared, because this times that I'm multiplying the same base. 0.02 times 0.02 is the same as 0.02 squared all over 0,19. Okay, because I'm trying to make this subject of the formula. So this one will go that side and that junk will come here. So we'll end up having what? When you punch it on the calculator, you will get your concentration being 2,11 times 10 to the power minus 3 moles per cubic decimeter. Do not forget the units. Remember the unit for concentration. So this is therefore concentration of COBr2 gas. And that brings us to the end of this video. Thank you very much, and continue liking, sharing, and of course subscribing to my channel. Thank you. Bye-bye.